Okay, so yesterday we talked about what is a nuclear reaction, and we talked about different types of nuclear decay, and we talked about decay and then also bombardment. Today we're going to take a little closer look at like how we use it and just kind of what's actually happening. So, first one, you're at the bottom of the second page where it says nuclear fission. And fission is when you take a nucleus and you actually break it apart. So this is usually what happens. So you take this heavy nucleus that's unstable and it falls apart into two smaller nuclei. Usually you have to get them started unless it's a natural decay. So you kind of induce it, you start it. But once you get it started, most of the time it keeps going. So a lot of times with this, it can be self-sustaining. When you do just one fission reaction, you get a really low amount of energy. It's not like a huge nuclear explosion or anything. It's just a small amount of energy. And fission is actually what we use in nuclear reactors. So TMI, you guys live really close to it. This is what's going on there. They take the plutonium or uranium and they actually break it apart. So there's two different types. They're either going to use uranium-235 or plutonium-239. They don't use both. I'm not actually sure which one TMI uses, but they use one, they only use one. So down here is an example of what's going to happen. We take our uranium. And again, uranium is radioactive, but we want it to get going. So what we do is we bombard it. We take a neutron and we actually hit it. So then what happens is it kind of gets stuck together and we get this unstable uranium. And then what happens is this unstable nuclei falls apart and we get krypton and we get barium. And then we also get these three little neutrons over here. So we actually get three products. The krypton and the barium, so this guy right here, this krypton and our barium, is what is our nuclear waste. They're not stable. They're really bad. So they're the things that actually kind of fall apart here. So we'll keep going. When we make these new nuclei, this krypton and the barium, they have way too many neutrons and they are very radioactive, very dangerous. This is the stuff you have to try and find a place to put that no one wants. So when we make this krypton and barium, it's not so good. One other thing though, if you look up, we had three neutrons. Those neutrons keep going and they actually cause more reactions to happen. So again, we're inducing it, we're starting the process, and then once it keeps going, it just kind of self-sustains, and that's called our chain reaction. So we get this nice chain reaction going at TMI, and they have to monitor it, and they have to keep it at a certain pace to actually keep it going. And you do need a certain amount, and it's called the critical mass to have a chain reaction. And that's why every so many years, TMI, they don't tell you they're going to do it, but they do have to change their fuel rods because eventually what happens is less and less uranium's left, and it's just that krypton and barium that's dangerous. So they need to get fresh uranium, and that's what that's talking about. And just kind of a picture. This is a nice color one. We'll look at the one in your notes as well. But again, we have this neutron. This is our uranium. It hits our uranium. It starts breaking it apart, so we start getting two things. One of these would be krypton. One of these would be barium. We get a little bit of energy, which is good because we are a power plant and we're trying to get some power. We get three neutrons. And those three neutrons can now go on to new uraniums and keep them going. This is the one you have in your notes, and it's a nice picture. What it does show you, though, is we start with one neutron, then we get three, oops, and then down here we have like 9. So we're increasing each time. We're increasing and increasing and increasing, and you have to be careful with that because you wouldn't want an explosion to happen. So they have to control that at TMI so it doesn't get out of hand. All right, so different parts of a nuclear reactor. Of course, you have your fuel rods, which is your uranium at TMI. They're going to be in the core, and once they've been reacted, they are going to be called spent, and that's when they have to get new ones. So they have to bring new ones, and they're never going to tell you. They usually release it to the media about a week after they're done because they don't really want someone to steal their uranium. but that's the fuel rods. There's also these things called control rods, because we just saw before it's kind of an exponential growth. So the control rods actually control how fast the nuclear reaction is going. And we don't want to have a nuclear bomb, we just want to have a nuclear reaction. So that's the control rods basically control that. We have this thing called the moderator. It's usually that heavy water, remember that deuterium, that heavy isotope, and what it does is it cools. So you have those 3 big towers at TMI. What they are doing is cooling all the time. If you didn't have that cooling, we would have a meltdown. We have a generator, which actually turns and makes turns steam and it gets turbines, and we'll talk about that in a second. Essentially, all TMI is for is it basically makes steam and it turns turbines. So you think this big thing with this big nuclear reactor, all they're doing is turning turbines with steam. And then we have those cooling towers that basically help us cool the steam back down. All right, so if you look here, right here with the green, that is where your control rods and your fuel rods are. That's where the reaction takes place. They're in this big building. It's all protected so no one can get in. And then what happens is the reaction takes place and it takes this water and it kind of heats it up. And what happens is it generates steam, and the steam goes through here and it turns turbines. And the turbines make us have electricity. And then the steam gets cooled back down. And it goes through the whole process again and again. So again, we're just using that nuclear reaction to help us make that steam for the electrical thing. So it's actually kind of far less exciting than you would think it would be, given that it is a nuclear reaction. All right, so that's fission. Now we have fusion. Fusion is the opposite. We said fission is when you break something apart. Fusion is when you actually put something together. So the first thing is fusion is going to require really high temperatures. This is not like a warm sunny day. We're talking like you're going to melt yourself high. And when you fuse, you are actually combining or fusing nuclei together. If you think back to when you were a little kid, maybe you did this. You had little pegboards. You put the little beads on them, and then your mom or dad ironed them. That you're fusing things together. Fusion is pretty good because it gives us a lot of energy, and it doesn't really give us much waste, which is really nice. And the things that it makes are actually stable. They're not radioactive. The problem with it is right now it only occurs in the sun and other stars and the hydrogen bomb. So this is not something that we can currently use. There's no fusion reactors. It's just we just can't control it. They need to basically, it takes a lot of energy to get a fusion going. So if we're going to use them, they have to make more energy than they're going to take. And right now it's not feasible. So if you've ever heard of that thing, or you've probably heard in a sci-fi movie about cold fusion, if you can figure out how to do fusion at a lower temperature, you would pretty much be like the richest human being in the world. You could kind of control the world. So that'd be kind of cool. And then right here, the biggest problem for us is the temperature. It's just too hot. We don't want to live on the sun, so it's really hard to do that. But if you look at this is what happens in our sun. Right now, we have this hydrogen. This is that really dangerous hydrogen, that tritium. It's getting combined with the deuterium. So these are both isotopes of hydrogen. The sun fuses it together, and it makes helium, a neutron, and tons of energy. This helium is completely normal. This neutron is completely normal. They're not radioactive. They're not dangerous. And we get lots of energy. So if we could do it, it would be really beneficial for us. But at this time, it just doesn't really work for us.